Good morning, or afternoon, or evening, or whenever you're watching this. Welcome back. Today we're going to talk about Pascal's triangle and binomial expansion, something just incredibly important in the world of mathematics. Not really, but it is something you need to learn how to do, something you need to learn to mess around with, play around with, figure out. It's just one of those things in mathematics that, we teach you so that you understand how mathematics works. It's just one of those things. So we're going to talk about this today, and hopefully you'll understand it. Again, if you don't understand it, then you might want to come, or shoot me an email, find out what's going on, see if you can get a hold of me for some help. All right, let's talk about this. Okay, so I think most of you realize that anything raised to the 0 power is 1. If I was to bring up my calculator, and I just simply said, okay, what is 4 raised to the 0 power? What is 0.2658 raised to the 0 power? Anything you do, it's going to be 1. No matter what, it's just going to be 1. So anything raised to the 0 power is 1. So I'm going to put a 1 right here. And then anything raised to the first power is really just itself. It's just this is equal to x plus y. And again, I can bring up my calculator and raise anything raised to the 0 power. 9 to the 0 power is 1. Now when you're doing negatives, don't forget you have to put parentheses, but negative 6.23 raised to the 1 power. Well, it's negative 6.23 once again. So anything raised to the 1 power is just 1. Anything raised to the 0 power is 0. So I'm going to write this as 1x plus 1y. Okay. Now let's do x plus y squared. And I think, we've talked about this before. Not worry about that. When you have this, you're just going to have a binomial times a binomial, which means we're going to double distribute. Used to be called FOIL. For those of you that your teachers still teach FOIL, it's the same thing. First, outer, inner, last. Double distribute. We're going to multiply x times x, and we get x squared. We're going to multiply x times y and get xy. We're going to multiply x or y times x and get xy again. And then we finally multiply y times y and get y squared. Anytime you're doing any kind of double distributing or triple distributing or whatever it is you're going to do, there's always a little bit of cleanup work to do. So, and that's usually the middle terms somehow, the middle terms are usually like or similar terms, and we can add those up. So in this case, it's just 2xy plus y squared. So off to the side over here, I'm going to write this as 1 plus 1x squared plus 2xy plus 1y squared. And I'm going to scroll down. I'll come back to that in a minute. Now, this cubed is nothing more than x plus y times x plus y. Well, we already know what this is. We just did that work. That's this. So I'm not going to redo that work, although I could if I had to. It's just x squared plus 2xy plus y squared times x plus y. I'm now going to triple distribute. Very complicated stuff. All right, we're going to multiply this x squared times this x, and I get x cubed. And then I'm going to multiply it times the y, and I get plus x squared y. And just for fun, I'm going to get rid of those lines, and draw the next one. I'm going to multiply 2x, so it's going to be plus 2x squared y, and then times this, it's going to be plus 2x y squared. And we'll get rid of those. Oops, get rid of too much. Go to green. Gotta put my parenthesis back. And then we're going to multiply. Oops, I got rid of that parenthesis too. Y squared times x. And I always put my variables in order. So x times y squared. Remember, multiplication is commutative. It doesn't matter what order you multiply in. It will always be the same product. And then y squared times y is y cubed. Okay. And again, we always have like or similar terms. You'll notice that both of these things can be combined, right? These both have an x squared and a y, an x squared and a y. So this gives me x cubed plus 3x squared y plus 3x y squared plus y cubed. All right, so that's a binomial cubed. I'm going to put that right here. 1x cubed plus 3x squared y plus 3xy squared plus y cubed. Now, for those of you that haven't yet figured out what exactly I'm doing, let me try to pick a really cool color. No such thing as cool colors. I'm creating a... Oh yeah, that's some amazing artwork right there. This is why I teach mathematics and not art. But I'm creating a triangle. I'm going to do this again. And I already know what cubed is. Now we're going to do it to the 4th power. So x cubed plus 3x squared y plus 3xy squared plus y cubed. Now that's x plus y cubed. And then we have to multiply again times x plus y. Okay, so now we got to do quadruple distribute. So let's do it. X cubed times x is x to the 4th. I'm not going to draw the lines. It's too much annoying. And then x cubed here times y would be plus x cubed y. Now we're going to multiply this one. So 3x squared y times x. So that's plus 3x cubed y plus, now we're going to multiply this times y, so that's plus 3x squared y squared plus, now we're distributing this one, 3x squared y squared plus 3x y cubed. And finally, we're going to distribute this one. X y cubed plus y to the 4th. Now, if I clean all this up, which isn't too bad, these can be combined, these can be combined, these can be combined. And I made this nice with just using x and y. Could you imagine? Oh, we're going to. If it is something a little bit different, like a fraction or a negative fraction, makes it a lot more difficult. So plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the 4th. And let me just go up here, write this up here for you. So we're going to have 1x to the 4th plus 4x cubed y plus 6x squared y squared plus 4x y cubed plus y to the 4th. Here, extending my amazing triangle. So what we're looking for, a lot of times what we're looking for in mathematics is patterns. Do we see some kind of pattern being developed here? Now, some of you who are pretty quick probably have already figured this out. Some of you need me to tell you, and some of you may need to hit the pause button to take a look at this and see if there's a way that you can, or if there's a pattern developing. So if you want to hit the pause button now, give you about 2 seconds, and then I'm going to put the next row on. Now I'm not going to do the work because I don't want to be here all day and you don't want to listen to me talking all day. So I'm going to put the next row on without having to do a lot of work. And let's see if you can figure out what the pattern is. Let me get another color up here though. How about we go back to red? So the next row would be, pause now, 1 x to the 5th plus 5 x to the 4th y plus 10 x cubed y squared plus 10 x squared y cubed plus 5x y to the 4th plus y, oops, forgot the 1 y to the 5th. Do you see the pattern yet? What if I asked you to do this problem? How many of you legitimately would be able to, because this is just to the 4th, you can imagine how many terms we're going to have. 11, just in case you were wondering. And all of the middles will have things that can combine, and you're going to have large numbers. Oh, could you imagine doing that and trying not to make a mistake? I mean, first of all, if your teacher is making you do this particular problem without showing you how to do it using Pascal's triangle, or another means, which we'll do in our next video called, well, it's the binomial theorem. We'll use that tomorrow. But if they haven't showed you, then that would be kind of ridiculous. Okay, so let's see if you can figure this out. I'm going to give you the numbers, or what we call the coefficients. I'm going to give you the coefficients in front. 1, 6, 15, 20, 15, 6, 1. Next one would be 1, 7, 21, 35, 35, 21, 7, 1. Well, those of you that have not seen it yet, let me draw some triangles in. Let me get some colors in here. Let me draw some triangles in. Do you see any relationship between these or these? Or I can do another color. Let's go whatever color this is. Any relationship between these numbers or these numbers or these numbers. Well, what it is if you take 15 and add 6, you get 21. If we take 20 and add 15, I get 35. If I take these 15 and 20, I get 35. Now let's go back and take a look at the exponents. Here's an x to the 5th, x to the 4th, x cubed, which is hard to see, x squared, x to the 1st. And really, there's really an x to the 0 here, but we don't really need that because it's really just 1. And what's happening with the y's? Well, there's really a y to the 0 here, but we don't really need that. Y to the 1, y to the 2, y to the 3, y to the 4, and y to the 5. So the second value in the parentheses is going up in their exponents, while the first one is going down. Let's go get a nice clean copy of Pascal's triangle. Nice clean. Let's see how many rows I can fit on this screen of Pascal's triangle. So let me get back. I'll choose blue. I like blue. All right, let's see if I can do this without the camera shaking too much. 1, 1, 1. That's how it's going to start. Now we're going to do these two added together. So we're going to, it always starts with 1. Then we add these two, and we get 2. And we end with 1. Then we start with 1. We add these two, I get 3. I add these two, I get 3 and 1. I'm not going to get a lot here. I got to start making this smaller. 1, 4, 6, 4, 1. 1, 5, 10, 10, 5, 1. Try to get to 10. See how neat I can be. 1, 6, 15, 20, 15, sorry, brain cramp, 6, and 1 again. That's a 15, just in case you're wondering. 1, 7, 21, 35, 35, 21, 7, 1. The thing I'm struggling with is my center somehow got a little off center. So I'm skewing my triangle to the left here a little bit. 1, 8, 28, 56, 70, 56, 28, 8, and 1. Then we're going to go 1, 9, 36. It's early. Let's see. Those of you that can't add very well, if I take 56 and I add 30, I get 86. But that's not quite 30. It's 2 less, so I get 84. Add these two up, 70 and 50 is 120, so that's 126. And then I don't really have to do any math. That's 126. That's 84. That's 36. That's 9, and that's 1. One more. 1, 10, 45. Here we go again. Well, the 6 and the 4 make 10, so I'll make this 90 plus 30. That's 120. The 6 and the 4 make 10, so I'll make this 30 and this 80. So that's 30 and 80. Yeah, 210. Add these two up. That's 26 and 26 is 52, so this is 252. And we just go downhill again. 210, 120, 45, 10, and 1. So if I was to ask you to do x plus y to the 7th, well, what you need to know is we got to use this row, the 7th row. You'll notice that we're going to use whatever row starts and ends in 7. If I asked you to do x plus y to the 8th, well, I'd have to come down and use the 8th row. If I wanted you to do x plus y to the 10th, I would use this row. Now, recreating this is not difficult. It certainly is not difficult. I think some of you with maybe some of this math down here, down at the bottom, especially those that hate to add or can't add or don't have access to a calculator right away, might mess this up. But clearly, if I had to ask you to recreate Pascal's triangle for one problem on a test and it was to the 9th, you'd have to recreate all of these numbers. It'd probably take you about 10 minutes. Not difficult, but not always the best way. So on our next video, working with the binomial theorem, I'll teach you a different way to do that. So make sure you stay tuned. For today, we're going to start working here. So I want x minus y to the 4th power. And I'm going to use Pascal's triangle to do it. So, come up here. I'm going to use row 4. 1, 4, 6, 4, 1. So I'm going to use that row. 1, 4, 6, 4, 1. Those are the coefficients. Those are the leading coefficients of what I'm going to be doing. Well, when I'm done, they're not going to quite be the leading coefficient because I don't have x minus or x plus y here. I have this x minus 3 now. So here's how this is going to work, and this is what I would like you to do. What we're going to do is we're going to use the leading coefficients, and after each one, we're going to put parentheses. Parentheses are really important in mathematics. And then we're going to do the next number, 4, and we're going to use 2 sets of parentheses. And then we're going to do 6 and 2 sets of parentheses, plus 4 and 2 sets of parentheses, plus 1 and 2 sets of parentheses. Now, in the first parentheses is going to go whatever is the first term in this binomial. Remember, this is binomial expansion. We're taking a binomial and we're doing it to the 4th, the 5th, the 6th, the 7th, the 8th power. In this case, to the 4th. So whatever is going to be here, this goes in the beginning one. X, 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 and X. In the second one, we're going to put in this one, which is negative 3. Yes, I know that's minus 3, but what we need to put it in here or think about it as being a negative 3. Because if you were doing distribution, you would be multiplying a negative 3 times whatever. Okay, now if you remember correctly with the exponents, when we dealt with the exponents, the first one started high and finished low. So we're going to start with whatever this one is. That's the first exponent here, 4. And we're going to go down, 3, 2, 1, 0. The other one starts low at 0 and goes up, 1, 2, 3, 4. Now, if you remember something I taught you earlier, anything to the 0 power is just 1. So really this and this one down here at the end to the 0 power aren't very useful because they're really just multiplying by 1. Well, we don't need that. So 1x to the 4th. So this is just x to the 4th. Now we've got to deal with our numbers. So I'm going to highlight these. We've got a 4 here and a negative 3 to the first power. So 4, well, negative 3 to the first power. Anything to the first power is just itself. So negative 3 to the first power is negative 3 times 4 is negative 4x cubed. Now we're going to deal with this number and this number. Well, negative 3 squared is positive 9, remember. And anytime you're going to have a negative, what you're going to see is these signs back and forth. One positive, one negative, one positive, one negative. For those of you that are pretty good at math, you understand that anytime there's an even exponent, and I have a negative number raised to an even exponent, that's always going to be positive. A negative number to an odd exponent would always give you a negative number. So this is positive 9 times 6. So that's plus 54x squared. Now we're going to do negative 3 cubed. That's negative 27 times 4. So now we're going to be negative. And anytime you multiply by 4, you just double. So 27 doubled is 54. 54 doubled is 108. So negative 108x. Notice it's just x to the first. And finally, we're going to do negative 3 to the 4th power. And that's an even exponent, so it's going to be positive. And that would just be 81. So there's your answer. Not bad. Fifth one. All right, so we know that's going to be, if you go look back, and we can look back at our table, our fifth row is 1, 5, 10, 10, 5, 1. So we're going to use those coefficients in our calculation. I'm just going to put those here so we remember. 1, 5, 10, 10, 5, 1. And there's always one more of these than this number. So in this case, there's 6 of these. So let's see if we can write this. 1 parentheses plus 5 parentheses plus 10 parentheses plus 10 parentheses plus 5 parentheses plus 1 parentheses. And if I'm ever going too fast or you're not understanding what you do, you can always hit the pause button, rewind, you know, and see if you can try it on your own. You know, I'm going to give you some time to try this next one on your own, but, you know, this works best if you just hit the pause button. Make sure I'm not making a funny face when you hit the pause button, but hit the pause button and then catch up. I go pretty quickly. So in the first one, we're going to put the x's. Remember, whatever's first in the binomial, that goes in the first set of parentheses. And in the second set, we're going to put this positive 3. Now, we don't need to put a plus because plus is understood to be there. That plus sign is understood to be a positive 3. We don't need to have the plus there. And now let me just grab another color just to be kind of festive. I'm going to start with a 5. So 5, 4, 3, 2, 1, 0. And then I'm just going to come around 5, 4, 3, 2, 1, 0. Now, if you remember what I said before, there's 2 of these parentheses that really just are 1 or multiplying by 1, and we don't need them. And that's this first one, and that's this one down here. So we can just get rid of those right now so they don't confuse us for later. All right, now we don't have negatives to deal with, so we got to be kind of loving that. That's kind of fun. All right, it's math. You're not loving it, but at least it's kind of cool. Okay, it's not cool at all, but it makes things easier. So, x to the 5th. Plus, everything's going to be positive this time because there's no negatives, which is nice. So now you got a 3 times a 5, so that's 15 x to the 4th plus, now I've got a 9 times 10, so that's 90 x cubed. This is 27 times 10, 270. X squared. Notice the x's are coming down. Now I've got, this is 3 to the 4th, which is 81 times 5. 80 times 5 is 400. 1 times 5 is 5, so this is 405 x. And call me out if I ever make a mistake. I want you to slam me, lambaste me in the comments. No, not really. I'm not really going to be that cared. But if I do make a mistake, you certainly can point it out so somebody else can see that hey, even us geniuses make mistakes. Okay. And this, by the way, is a 5, even though it looks nothing like a 5. Let's see. Those of you, let's just resort to calculator so we don't need that. We're going to do 3 raised to the 5th power equals 243. And it's really just 81 times 3. So 243. And there it is. In all of its glory. I'm finished. Move on to the next problem. All right, let's try another one. If we remember correctly, this is going to be 1, 4, 6, 4, 1. So 1, 2 sets of parentheses. Plus 4, 2 sets of parentheses. Now, in the next video, binomial theorem video, I'm going to show you typical kinds of questions that are asked. These aren't really typical kinds of questions. This is just getting you practice on getting to expand a binomial to whatever degree it is using Pascal's triangles. But these really just aren't typical questions that are being asked. Typical questions that are being asked, you'll see in the next video series. Again, it's the binomial theorem video series. Normally they'll just ask you for one of these terms. And I think actually using Pascal's triangle to find one term is sort of difficult. It certainly isn't as easy as what I will teach you in that one. This is 2, 3, and 4. And let me get rid of this comma that I drew here for whatever reason. And blue. And we put A here, and A goes in all the beginnings. And just to save myself some time, I'm going to put the 2B in the second one. To be or not to be. I'm going to guess that was Shakespeare of some times. I have no idea which play. Okay. Again, I don't need the zeros. Those are just there to help me make sure I had my exponents correctly. Because sometimes if you're lazy and you just leave those out, what's going to happen is you're going to have the wrong exponents on things and you're going to screw things up. All right, again, hey, no negatives. So we should be in good shape here. This is going to give me a to the fourth. That's easy. Plus. Now, we do have more than one variable, so we got to be careful now. So this is going to be 2 to the first, which is 2, times 4, which is 8. A cubed, but b to the first power. Now remember, the a's are going to come down and the b's are going to go up. So every time we should be seeing the b's have a higher exponent and the a's have a smaller exponent. 2 squared is 4. 4 times 6 is 24. A squared, notice the a came down, and b squared, b went up. Plus 2 cubed is 8. 8 times 4 is 32. So 32. Now it's just going to be a to the first, b cubed, plus, no more a's, we're done with the a's, 2 to the fourth, that's 16, b to the fourth. That was a simple one. Getting faster. Hopefully the next one doesn't have a negative. Oh, it does. But it's only to the third, so this one's actually not that bad. So, if you remember, the third one was 1, 3, 3, 1. I'll save us a trip back to that earlier page. Those are the coefficients that we're going to use. Only 4 terms. Remember, the number of terms here is always 1 more than whatever my exponent is. So 1 to 2 sets of parentheses. If you hear that, that's my heater that just came on. I'm in my basement, in my unbelievably cool studio. It's actually just cold. And that shivering you see on the camera is just because I need a better table to put this on, and I will get one soon. So that it's not so much shake when I write. All right, we got to be careful here. The 5 goes in the beginnings, and I'm going to just put those 5s in there. I'm going to put the negative 2y in a different color, just to really drive home a point that this is going to be tricky. Not bad, just a little trickier. And anytime you deal with negatives in mathematics, it really should send to like those hairs on the back of your neck that go, okay, you got to be careful. Be careful with the negatives. They always provide some level of more difficultness. Okay, that's not English, but it's good enough. 3, 2, 1, 0. We're going to turn around and come back. 3, 2, 1, 0. Now we can get rid of those ones that just helped us. The helper ones. See ya. All right. 5 cubed. That's 125. Now, remember what I told you about the negatives. One's going to be plus. One's going to be minus. Every other one's are going to be positive. One's going to be negative every other time. So, negative 2 to the first is just negative 2. 5 squared is 25. So it's at this point I would recommend to kids, why not take out your calculator and put this stuff in? It's pretty simple. If you're smart at math, should you be using a calculator? I always say if you're a good math student, the calculator should very seldom come on. I think you should be able to do things in your head. If you're planning on doing well on the SATs, you really need to be able to do stuff well without the use of the calculators. If you're going to use it, though, make sure you're using parentheses and you do things correctly. Now, I don't need to put to the first power because it's already there. So this is going to turn out to be a negative number. Negative 150, yes. Because this is negative 2, this is 25. 25 times 3 is 75. 75 times 2 is 150. So this is negative 150. Y to the first, or just y. Now the next one's going to be positive, because remember, every other time is going to be positive. And again, I can take my calculator back out. I'm not going to. This is 15. 15 times positive 4 is 60. Y squared. Done with that one. And then this is negative 2 cubed is negative 8. It is not negative 6. It is negative 8 y cubed. Now, this is our answer, but I'm going to tell you if you were in my class, this would be wrong because I don't like answers not written in standard form. And standard form says we write them with the highest degree first, and cubed is the highest degree, so that should come first, then the squared, which is the plus 60, y squared, then the y term, 150y, and then plus 125. Oops, forgot the 125. This would be the best answer. I would take off with that, but I'm a really mean teacher. Getting close. I think I've just got one left. Oh, we got two left. Again, at any time you want to try this on your own, stop. Do it on your own. I'm going to tell you 1, 4, 6, 4, 1 from Pascal's triangle, the numbers we need. 2 problems left and we'll be finished with this lesson. Parentheses, 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 parentheses. Almost there. Oh, 4, 3, 2, 1, 0, 0, 1, 2, 3, 4. We're going to put a 4 in the first one, a y in the second one. A 4 in the first one, a y in the second one. 4 in the first one, a y in the second one, a 4 in the first one, a y in the second one, a 4 in the first one. Anybody get tired of me? Did you get tired of me saying that? It's kind of annoying, isn't it? Shut up. All right, let's get rid of the zeros. All right, even I get a little punchy and a little crazy after a while. 4 to the 4th power. Let's see if we can do this in our head. 4 times 4 is 16. Double 16, 32. Double it again, you get 64. So 4 cubed is 64. Now we're going to double that and double it again to get to multiply by that last 4. So you double 64, you get 128. Double 128, you get 256. So 256, no y's, plus, now really, this is 4 to the 4th power again times y. So now we're going to do 256y plus 4 squared is 16. 16 times 6. Now let me just show you something. 16 times 6. I don't ever multiply 16 times 6 because I don't really do it. What I do is I do 6 times 1, which is really 10. That's 60. And 6 times 6 is 36. So that's 36 and 60. That's 96. Y squared plus 4 to the first is 4 times 4 is 16. Y cubed plus y to the 4th. And again, this is not written in standard form, so we should write it y to the 4th plus 16y cubed plus 96y squared plus 256y plus 256. Last problem. Oh, man, that's not true. I got 2 left. I'm only going to do 2 more because I think this is enough. I'm going to do this one, and I'm going to do the last one because it's a lot. And then I'm going to be finished. So 5, if you remember correctly, it's 1, 5, 10, 10, 5, 1. Some of these I have memorized, some of these don't. I hate memorizing anything in math. I just like doing math and figuring things out by myself. And I think anytime you have to memorize certain things, there are certain things you just should have, boom, knock, cold, just know without, if I was to ask you what 7 plus 3 was and you didn't, and you had to think about it, that's just not good enough. Let me change colors. I got a little old. 5, 4, 3, 2, 1, 0, 5, 4, 3, 2, 1, 0. X and minus 2y. But I don't need this one, so I'm going to get rid of it. X and minus 2y. Notice we're back to having a negative, right? So we're remembering that every other one of our terms is going to be 1 positive, 1 negative. Every other one's going to be negative. All right, I jammed that in. We don't need this one. And let me get to my green. Green's just such a friendly color. 1x to the 5th. Now, remember, I haven't been told you, but I don't need to put that 1 there. Right? You guys know that. All right, so this one's going to be our negative one. So negative 2 to the 1st, negative 2, times 5, negative 10, x to the 4th. Notice the x's are coming down, but the y's are starting to appear. Now, I could put a y to the 1st there, but that's kind of stupid. Now we're going to have a plus. Negative 2 squared is positive 4 times 10 is 40. X's are coming down, cubed. Y's are going up, plus. Negative 2 cubed, we've talked about this before. And here I am, I made my first mistake. It's probably not my first. Someone's going to call me out on something I did. So it's minus. Negative 2 cubed is negative 8 times 10 is negative 80. X's are going down, Y's are going up. Negative 2 to the 4th is 16. 16 times 5, hopefully you know, is 80. X to the 1st, Y to the 4th. And finally, we'll just end up with Y to the 5th. And this is fine. It's written in good enough order. All the exponents add to 5, so this is in standard form. Okay, moving down. That one's too easy. We're not going to do that one. I'm not even sure why I put that one on there. This one's a little tricky. Let's do this one. It'll be our last one. I have no idea what the 7 one is. Lost my... So I'm going to have to go all the way back up here and go. 7 is 21 and 35. So it's going to go 1, 7, 21, 35, 35, 21, 7, 1. And there are 1, 2, 3, 4, 5, 6, 7, 8. So I think I have that right. Now I really am going to have to draw small to get in here. So for those of you with vision problems, you might have to squint a little. Sorry about that. 21. This is where you fast forward so you don't have to watch me doing this. I wonder if there's a way I can fast forward on a video. But if you're trying to follow along with me, fast forwarding on a video would be just kind of dumb. Because then you'd be like really frantically trying to keep up. Plus 1, parenthesis, 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 parenthesis. Oh, it's going to let me right over there. Did I get them all? I think I did. Let me change colors. It's kind of annoying to look at. So the exponents are going to be 7, 6, 5, 4, 3, 2. I missed one. Son of a gun. I knew I missed one. I missed it all the way back here, too. You probably are following along going, oh, you dummy, you missed one. But that's, see, that, you know, that's the beauty of having all those parentheses out there. I knew, you know, when I didn't get to 0 there, I knew I missed one, and I could figure out where I put it. Or I figure out not where I put it, but where I missed it. Nah, I'm running out of room, so I'm just going to go to this next. I'll just put a plus, and then it's 7, parenthesis, 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 plus 1, parenthesis, 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 parenthesis. You can imagine how obnoxious this would be if this was in, you know, to the 10th, you know. Teachers should really be asking you to do that, because that's just craziness. And then we'll come back. 7, 6, 5, 4, 3, 2, 1, and 0. And let me put those in. K and negative 3. But this one, again, I don't need. I just use it so I don't make mistakes like I just about did. And I might have continued to make that mistake had I not had all those parentheses there to see that, oh yeah, I'm missing one. So it's always in your best interest not to be lazy. But again, watch the next video, Binomial Theorem, to see how we can use that theorem, instead of doing all this craziness, how we can use that theorem to speed things up slightly. Let's see if I can move down just a little bit. Almost finished here, kids. Here we go. First one's going to be k to the 7. Now I may end up using my calculator on these. Plus Maybe not. Negative 3. Oh, somebody was smart enough to realize that, hey, every other one's going to be negative. Come on, Mr. Krause. What are you doing? Every other one's going to be negative. So negative 3 times 7. Negative 21. K to the 6. Notice these are going to come down. Next one is going to be positive. This is 9 positive times 21. That's 189 k to the 5th. Again, that's 9 times 20, which is 180. 1 times 9, which is 91. Or 9. Minus. Now we're going to use our calculator. Because this is, now we're just going to grab the calculator. Boom. And it's 35 times, parentheses, negative 3 raised to the 3rd power. And that's 35 times negative 27. Don't have any trick for that. That's just negative 945. K to the 4th plus. Now I know this is 81 times 35, but again, don't have that memorized. So I'm just going to do 81 times 35. 2835. Everybody knew that one. K cubed minus hit the wrong button, sorry about that. Let's see, what am I going to do now? I'm going to do negative 3 to the 5th times 21. Let me just do that. Make sure I don't make any dumb mistakes. Negative 3 to the 5th times 21. Notice it doesn't matter what order. Oh, man, that would make a huge difference. Notice I'm still in exponent mode. I got to get out of exponent modes. Times 21. I would get some crazy number. Negative 5103. 5103 k squared. Now I'm going to do negative 3 to the 6th times 7. You know what? Let's do this. Save myself a little bit of headache. Oops. To the 6th. I'm not sure this helped. I'm not sure that was faster. Times 7. Positive 5103. Okay, and then finally the last one is just negative 3 to the 7th power. Parentheses, negative 3, parentheses, raised to the 7th power, and we get negative 2187. I hope that you can imagine how difficult this is, or would be, if you had to the 10th power, to the 11th power, 12th power. Nobody really would ask you to do that, other than to see if you are really crazy enough to do something like that. So in our next video series, again, binomial theorem, it uses combinatorics, and I'll teach you that. If you haven't been taught that before, I'll teach you that very quickly. Not going to get into it very much. Very simple concept. But it will teach you how to get those numbers very quickly, and how, instead of if I had gave you this problem and I said, okay, can you tell me what the 4th term is? Can you come up with this term? That's the 4th term. Can you come up with that term pretty quickly? Or do you have to go through all of Pascal's triangle to do that? I don't think you do. So that's on the next video series, or on the next video. Hope you enjoyed this. Shoot me an email if you have any questions. If you are enjoying these and you would like to subscribe, you'll know I'll be putting up videos quite regularly. I will also be putting up New York State Regents exams videos as well, so that when it comes time to review at the end of the year, for those of you that are going to be retaking this in January or need to retake it in summer, you have those videos available to you. So you can subscribe to my YouTube channel, and you'll just get updates on when my new videos are posted. If you'd like to see something earlier than is planned, and I don't yet have a calendar or a plan yet of when I'm going to be doing videos, kind of is when I have time. But I'll be getting them up. But if you'd like to see something early, shoot me an email, let me know. All right. Take care. Have a good day.